I would now like to talk about what happens when the right-hand side of our non-homogeneous differential equation is a linear combination of functions of t. So I'm going to consider a linear differential equation with a right-hand side that I'm going to call forcing function, but that will make a little bit more sense when we talk about the next video. But that right-hand side is going to be a linear combination of two functions. So it's going to be k1 f of t plus k2 f2 of t. So what I'm saying is I now have a new second order differential equation. It's going to be Ly is equal to k1 f of t, f1 of t, plus k2 f2 of t. So it's a linear combination of two forcing functions. Well, then that means that I'm going to need a particular solution that corresponds to that linear combination of f1 and f2. But what if I happen to already know a particular solution to the problem Ly1 equals f1 and then Ly equals f2? So I know that yp1, that particular solution, solves Ly equals f1, and I know that y2 solves Ly2 equals f2. So essentially, I solved for the two particular solutions separately. Well, then if I take a linear combination of the particular solutions, that will indeed solve Ly equals the same linear combination of the right-hand side. Let's see how that works. If I do L to Y, I'm going to get L done to a linear combination of my particular solutions, K1, P1, plus K2, YP2. And if I distribute the L, that becomes K LYP1 plus K2 LYP2. But what is LYP1? It is actually F1. Okay, and what is LYP2? It is F2. So by taking the same linear combination of the particular solutions, I can then solve the problem where the right-hand side is a linear combination of the functions that corresponded to those particular solutions. Let's see this as an example. I want to solve that same differential equation, y double prime plus 2y plus 2y prime minus 3y is equal to t squared plus 3 sine t. Now, I actually solved the equation when the right-hand side was 27t squared. And I also solved the equation when the right-hand side was 30 sine t. So I can use the particular solutions from solving the equation with 27t squared and when using the particular, and use the particular solution when the right-hand side was 30 sine t. So I can tell you right off the bat that y of t is going to be the homogeneous solution, c1 e to the minus 3t plus c2 e to the t. And then it's going to be 1/27th of the particular solution when I solved for 27t squared, which was minus 9t squared minus 12t minus 14. And then it's also going to be 1/10 of the particular solution for 30 sine t, because now my right-hand side is 3 sine t. So it's 1/10 of my particular solution for the 30 sine t, which was negative 3 cosine t minus 6 sine t. And if you like, you could distribute the 1/27th and the 1/10th, but this is actually the general solution. So it's the homogeneous solution. Then it's a multiple of the particular solution for 27t squared being the right-hand side, and then a multiple of the particular solution when 30 sine t was on the right-hand side. And that shows you how you can use the principle of superposition to solve a non-homogeneous differential equation that's linear when the right-hand side is a linear combination of several functions.